Hello, everybody. Welcome to the first Ask Tom office hours session for spatial technologies in 2025. I'm happy to be the host for the session today. I have some guests with me, so let me jump directly to the agenda and to show you who will be our guests today. So we will be starting today with a topic of Oracle Analytics Cloud supporting native geometry data in the Oracle database, meaning supporting the data type as your geometry. And Philippe Lyon from the product management for Oracle Analytics will present that topic. Furthermore, we have Rahul Tasker with us. He will be talking about caching vector types in order to improve performance when loading large sets of vector data and mapping those in your applications. And last but not least, I will be presenting first insights and tests with Select AI and to generate SQL queries that use spatial functions and operators. My name is Karin Patenga. I'm part of the Oracle product management team, and we have more members of the Oracle product management team with us in the call, as well as colleagues from Philippe Lyon's team. So there's plenty of expertise to answer every question you have. If you are interested in seeing the recordings of previous Ask Tom sessions about spatial technologies, just go to the Ask Tom portal. There are the recordings available as videos, and search for the Spatial for DBA's Analysts and Developer Office Hours series. And there you have the links to all the recordings, presentations we have done in the past. I would like to encourage you to tell us if you're interested in specific topics we should cover in one of our future Ask Tom sessions. If you have a topic we should talk about, then let us know about it. Send us an email. This is the easiest way. Just use the two email addresses over there. It's my email address and another colleague from our team here in Germany. So will be taking care for your questions and see how we can fit those topics into the next Ask Tom sessions about spatial technologies. You can also use Stack Overflow and post your questions over there. So any kind of spatial related question you have, either post it in Stack Overflow or in the Oracle forums. We monitor both channels and look for questions you might have, and hopefully we don't miss any of them. So be aware to, or please tag your questions accordingly so we can easily find them. And of course, we will make sure that you get an answer as soon as we get to know about your questions via these two channels. Okay, so much for the intro and for the housekeeping. And now I would like to hand over to Philippe Lyon to tell us more about what's new in Oracle Analytics Cloud with regard to supporting working with spatial data. Thank you.
Thank you very much, Karin. Thank you. So I want to thank you first, Karin, for giving us the opportunity to talk about Oracle Analytics here in this event. So thanks, and good morning, good afternoon, good evening to everyone. My name is Philippe Lyons, and I'm working in the product management department of Oracle Analytics. And I'm joined here today with Gautam Pisharam. He's here to also answer Q&A. So he's also part of the team, the product management team. We want to talk to you for the next 20 minutes about Oracle Analytics and how it consumes and visualizes geometry data types from the database. Oracle Analytics is a product as part of Oracle that helps business users and analysts. So I want to insist on the word business users, not specifically data analysts and technical people, but also functional people to visualize their data. And let me actually share my shared. Okay. Hopefully you can see the screen coming up.
Yes, we can see. Yes.
And I will cut the video just to save on bandwidth. So Oracle Analytics allows to visualize data from any source, any data type, and not only geometry, of course, and not only database, but of course the connections and the integration that we have with the database capability is very, very powerful. And there is much that we could say about types of visualization and everything that Oracle Analytics can help users with, but today we want to focus on how powerful it is at natively visualizing geometries and in particular database geometries. So I'd like to break it down into three, show you a little bit of the value of geometry data in Oracle Analytics, and then how it can support and leverage spatial calculations that are natively being sent to the database, and eventually how you can go even further deeper and leveraging all sorts of SDO calculation in the database. So the SDO calculations are all sorts of spatial functions that are very powerful and very valuable function. So that's my last slide. And I will go with a live demo pretty much all along this presentation. So wish me luck with the connectivity. So let us start simply by talking about geometries and the values of leveraging geometries in analytics world. So here is a set of files where I have some geometrical data. So this is not yet in the database, but this is geometry data as with a specific format called WKT. And why is it valuable for me as a business user? I just dragged this file here in Oracle Analytics. Of course, it already exists. Call it V2 here. And this will add my data here. And these are columns in my data file, but one of these columns is a WKT, so geometry. It's the name of the column is WKT, but it happens to be a geometry data set. And when I double click on it, immediately a map appears on Oracle Analytics, and I see all of my geometries here represented on my viz. This is natively, there was not specific configuration Oracle Analytics to show this. This came up natively. I'm just going to change the background so we have a little bit of a funnier background here. And these are buildings in Paris, or a suburb, not a suburb, a quarter of Paris. Of course, then I can visualize with all sorts of attributes, coloring, and so on. Now, you can appreciate that this is of great value for me as a business user. Let me actually do a little bit of fun here. So I have just colored my map with some attributes that exist in my data. I don't even know what that attribute is about, but it's colorful for sure. And as I'm building this in front of you live, I can simply, how about zoom on a specific building, one or another one, and just go from one area in the map to another area in the map, and you can see how the map reacts and zoom and jumps from one place to another one. So this is very valuable for me as a business user to be able to consume geometries as they exist in my data sources on my maps. Fair enough. Last quick thing about maps, I can easily pile up more data. So saying, okay, we're seeing, let me get rid of this filtering here. We are seeing some data, and we want, as a functional user, to add more other geometrical layer on top of it. In fact, I should have added a data set maybe before. Let's go and drag another data set. How about we also drag restaurants into this? And we're going to call it restaurants tree. So this is data that I have in my CSV files, which I'm dragging. We're not yet in the database world. We're coming there in a second. But this data I just dragged into Oracle Analytics, and I'm going to plot whatever restaurants locations on top of my map. So now business user, very easy for me to handle. And now I'm seeing all my dots representing restaurants. Let me make this a little bit smaller. How about we make it 5? Now you see all the dots. And if we go down in the details, we can see all that. Now, of course, there's calculation that we can do with this. But before we do this, I want to show you that the same is exactly possible with the database data source. So if you see here on the top left, I've already created a connection in Oracle Analytics that points to a database. And the database here, just like I was showing you buildings, the database holds geometry data from the geometry data type, Oracle database, with customer assets location. So again, if I double click on this immediately, this is showing me all the assets that I have. This is supposed to represent my customer assets and on a map. And of course, I could do the same and color this and slice or visualize it in different ways. But here again, with the database, I may want to say, I would like to overlay a database geometry layer that could represent a storm path. So again, here, let's say in Spatial Studio, for instance, I have uploaded some data in my database that is representing the path of a storm. And I would like to overlay this over my customer assets. I'm just going to drag my geometry, database geometry, right away on my visualization. And here's my path. So just like you're probably familiar with the database tools such as Spatial Studio, I can do this in Oracle Analytics, consuming exactly the same data or consuming the results of calculations that have happened in Studio. The difference is that I am a business user and I don't have access to Studio and I don't have the technical skills to even go there, but yet I can still consume what David has built in Studio, the calculations he may have built in Studio. And I can go further here. I can even add some calculations in Oracle Analytics of a geometry type. So there are calculations, spatial calculations, such as geometry area, geometry distance, geometry length, relate, and within. So these are calculations that will leverage the capabilities of the database. So let me go and show you an example of that. We have created calculations in this, where I'm just watching time, so I'm saving you from the syntax of building the syntax of this. But if I edit that calculation, this is geometry within distance comparing my customer assets, this column, with my storm path, that column. And in this case, it's looking at every asset that is within a distance of 350 kilometers, and that's what the calculation is doing. Now, if I use that calculation in my viz, it's showing me all these customers. Actually, let's do a little edit to this. Let's make it be 550. Hopefully, we'll get a little bit more customer sets impacted within that. And you can see it went larger. Now, I don't want to go too much into technicals, but what is going on here behind the scenes? I'm going to show you the log for this visualization. Oracle Analytics is not doing much here besides sending the SQL, so the right statement to the database. I'm taking you to the details. This is the SQL that Oracle Analytics is sending to the database. And you can see here that it is properly, natively leveraging the capabilities of STO calculations in the database. So this results was fast and powerful because it was what we call function ship, so sent to the database with the proper expression by Oracle Analytics. Within distance is one example, but you saw me also do some distance, for instance. So if this is a distance calculation, let me, why don't I put this into color? Hopefully this is going to show us different colors depending on how the dots are. The calculation is probably not doing the right thing. I should have an average. But whatever. The calculation here is happening as well within the database and calculates the proper function to the database. This is enabling me as a business user to fully leverage STOs and powerful capabilities of the database directly, natively. Now, if I go one step further, I can create all sorts of visualization with this. Here is the exact same calculation showing me, what this is comparing counties. The little geometries are counties with the same innate storm path, but the storm path has been buffered. So in Spatial Studio, we've calculated a buffer, generated a geometry, and now OAC can leverage and consume that geometry. And then it's identifying, OAC, Oracle Analytics, is identifying what are the counties that are adjacent or touching the limit of the geometry, or what are the counties that are exactly included, fully included inside that path, or what are the counties that are in a distance of 350. That's what we did a minute ago, but it's a different visualization. It's not dots, it's counties, so it's a geometry to geometry. You can think of how many different visualizations and values a business analyst can extract out of leveraging these calculations and these geometries. So what I've done so far, if I go back here, is I've shown you how we could, the value of visualizing geometry data in Oracle Analytics from CSV or from database, and the value of, for me as a business user, building these calculations and having them function ship to the database natively. That is transparent to me as a business user. Let me take another 5 minutes to now show you how deeper we could go. So far, you've seen me build calculations which were, we did this, spatial calculations right there. So this is Oracle Analytics spatial calculations. Hopefully you can read it well enough. Geometry area, distance, length, relate within distance, and text. So this will properly being sent to the database. What if I want to go a little bit more sophisticated? Here's an example of a line, actually a shortest path between 2 points. And again, this is Oracle Analytics, and it's showing me a route. So it's a geometry in Oracle Analytics. Just like I dragged a moment ago, Paris restaurants or customer assets at risk, this is a geometry that exists in the database. But in this case, instead of having a calculation, I went directly in Oracle Analytics and defined a data set that was, in fact, this data set was itself a select statement. So this is defining my data set. We could have done this in Studio as well, but we did it directly here in Oracle Analytics. This is my own data set, and it's calling some specific SDO that requires 2 addresses, and that will find that drive the shortest path between these 2 addresses and generate a geometry out of it. My data set calls the database, generates the geometry, and that geometry then renders the route in OAC. So now I'm calling basically any type of SDO directly by configuring my data set, calling that statement. If I go one step further, here is a geometry in Oracle Analytics. So this is a geometry and a point. So this is a map with 2 different layers, a point and a drive area. And that geometry, just like I showed you a moment ago, instead of calculating a route, it's calculating a driving distance of 15 minutes around an address, which in this case, I think is Nashua, if I'm not mistaken. But whatever, let's pick another address. I think I have 2 addresses. Well, yeah, sorry, let me take another address here. And I don't know these addresses by heart. In fact, if anybody wants to Slack an address, I'll use it. Sorry. Okay, so here's one address. Let me call it.
Maybe Maddie can share one.
Here is one address. Well, I have it.
Okay, perfect.
So here is whatever. That's Washington. That's Microsoft. Now this is the same polygon. Now this was not computed ahead of time. It's on the fly because that data source is behind the scenes, simply calling the database, passing the address information as a parameter. Database computes the distance calculation, generates a geometry, and OAC simply consumes it right ahead on the browser. So let me try something a little bit more fancy. What if I go with a French address, and that's my address. events. I doubt that. So this is my address. Let's see how far I can drive from where I am. So now we're going to France, and here's my perimeter, my driving distance, which, overall is all correct. That's a city name somewhere in France, and I keep saying France because that's where I'm from. This is Paris. How about Reading? So you can see that for me as a business user, having the ability to call out the database capabilities in representing geometries or even calling for some calculations, just like I'm doing right now. Here, of course, connection is being able to do this for me as a business user. It's extremely valuable. You've seen me do overlap. What customers were in that shape. Now you're seeing me basically parameterize these shapes. If I can combine all of this together, this is extremely valuable for me as a business user, and it's actually possible only because of the capabilities that exist in a database and the fact that OSC can call them natively. I think I'm over with my 20 minutes here. I'm looking forward to, I think Gautam and I are looking forward to for interacting with you on all of this. If you have questions, and we'll be happy to take them, and looking forward to interacting with you via email if you have any other questions.
Yeah.
Thanks a lot, and thanks, Karen.
Thanks a lot, Philippe. Maybe we can pick up the question Martin has, and he is asking, what is the difference with Oracle Spatial Studio? And maybe you can answer it from your perspective, and then we can just add from our perspective, since we are responsible for Spatial Studio.
Yeah, great question. Oracle Spatial Studio is very powerful and brings the capability for people doing spatial calculations, spatial analysis to the right level. Oracle Analytics is a business user solution that will allow to visualize results of Oracle Spatial Studio. So you've seen me do some distance calculations. You've seen me do some visualization of different layers on top of each other, and basically call out results of what Oracle Spatial Studio is doing. So they are perfectly working together in the sense that one is where heavy lift calculation will happen on spatial calculations, right? Spatial operations. The other one is where you will natively and quickly visualize this. And when I say natively is when something changes on Studio side, it changes as well on the OAC representation of it because it sources from the same database table or view. So they go along together. You can do a little bit of a calculation within Oracle Analytics as well, but or you can even call some SDOs if you know what you're doing, like I showed you. But really, the place for doing the calculation is Studio. The place for showing it to the masses would be Oracle Analytics. So hopefully that, tell me what you think. I think David is also on the call.
Yeah.
Karen.
Maybe we can add to that. Spatial Studio is meant for those users who deal with the earlier stages of data processing or data analytics workflows focusing on spatial data. So Spatial Studio is meant for loading spatial data, verifying if the data are correct, plotting them on a map, seeing whether the data sets are correct, and doing analytics with based on spatial data sets. Also, one of the important topics for spatial analytics is that Spatial Studio has a built-in geocoding function and reverse geocoding. So address data, which are very common data sets, can be turned into geographic coordinates, which then can be used to plot the information on a map. So this is part of Spatial Studio, and it's meant for users dealing with spatial data sets. Oracle Analytics is much broader in terms of integrating with all types of different data, all types of different types of visualization. So you can do much more in terms of graphical representations of different types of data. But everything goes together. There are some overlaps with regard to functionality, with regard to visualization, but every tool has its own audience,
Oh
I
yeah,
would say.
yeah.
So business analytics users tend to use OSC. Data engineers, spatial data specialists tend to use Spatial Studio.
Yes, and the second question, and I'll real quick. So but yes, the results. Once you're in Oracle Analytics, you're in a solution that exposes dashboards to the world. So that's the whole point of Oracle Analytics, is to be able to build visualization and share them in a secure way with as many as users as you want. So yes, it's meant to be exposed to end users. Exactly. Thanks, Pasha.
Okay, perfect.
Thanks
So
again.
any other questions? If not, then thanks a lot again, Philippe, also Gautam. Yeah, as I said before, if you have any questions you think about later today or during the next days, you know which channels to use to ask us your questions. So we will take care for it also after the session. Okay, then it's time to hand over to Rahul. Rahul, the stage is yours.
Awesome. Thanks, Karin. So let me share my screen. Just share my desktop here. Okay. Hi, everyone. I'm Rahul. I'm here from the Spatial and Graph Product Management team, and today I'm going to talk to you guys about vector tile and vector tile cache. So first, we'll cover what are vector tiles. Essentially, vector tiles are chunked representations of map data represented by a widely adopted open standard format, commonly used to efficiently stream spatial data for web applications. So vector tiles are commonly used, are a type of map data format commonly used for efficient rendering of geographic information at different zoom levels. So these tiles are commonly used in modern web applications because they're lightweight, customizable, and scalable. So if you think about your map as a grid, a vector tile would be a square on that grid. And then you can, as you zoom in and out on the map, the vector tiles become smaller as you zoom in to show more detail, and kind of become wider as you zoom out to show less detail, right? And so that allows for dynamic styling, smooth zooming experience for the end user and application, etc. And so in previous versions of the Oracle database, generating vector tiles required some kind of mid-tier, whereas in Oracle Database 23 AI, vector tile generation is built into the database. And we'll see that in a little bit. And so we can now, in 23 AI, use this get vector tile function to query a vector tile from a table using the get vector tile function, right? By specifying the table name, the geometry column for that table name, any attributes we want to include, as well as the X, Y, and Z axis, we can get a vector tile back and return it to an application. We could do that either from a table, or we could achieve the same thing through a query, right? And so vector tiles are typically consumed through some API. So JavaScript libraries expect a standard PBF format, which will automatically update and the client libraries will typically automatically update those Z, Y, and X attributes. So that means that, within your application, you don't really need to do that on your own. That's just something that will be handled by the client library and then returned to the application, right? So the client libraries consume the vector tiles through an API and render the map for the application. So the way that we do that at Oracle is we would expose these vector tiles through Oracle REST data services, right? So we can create an API for those client libraries by exposing the vector tiles through ORDs and give you the ability to, make this get vector tile call from any REST client. And so the call would look something like this, right? So notice that it's in the same format and structure as the vector tiles as how vector tiles are typically consumed. And we have these curly braces around Z, X, and Y so that those can be updated by the client library. Okay, so that's like a brief overview of what vector tiles are. Now, specifically today, with the rest of my time, I want to talk about a vector tile cache, right? So what is a vector tile cache and how do you use it? So the vector tile cache is planned for next month. And basically, this gives you the ability to cache the results of your get vector tile function. So you can enable or disable the cache for a table or for a geometry column and a specified zoom range, right? So the default zoom range is between 0 and 23, but you can specify, pretty much anything. This includes automated cache maintenance through some triggers on the source table. So if you make any updates to the table, it will be reflected in the cache, as well as procedures to enable, disable, and purge the cache. So if you want to clean it up, you can do that through a purge operation. And lastly, the owning schema of the cache can also grant and revoke access to other users in the database using like a grant procedure, right? And so without a vector tile cache, this is the typical flow of how working with vector tiles would typically work. Right, so you run a get vector tile function for the table name, the geometry name, and the Z, X, and Y. That will get the tile from the base table and return the tile to whatever client you're running this function from. In most cases, it would be to some end application, right? But with a vector tile cache, the first thing you want to do is enable a vector tile cache by specifying the table name, the geometry column, and the minimum maximum zoom. And then from there, that will add rows to the SDO tile cache info metadata table, including, those parameters that you specified in the enable vector tile cache function. And then when you run the get vector tile function, it'll do a few things. So first, it'll check the cache for the tile. And so then if that tile exists, it will return the tile back to, your client application, right? But if the tile isn't found, it'll get the tile from the base table and return the tile just like it would without the cache, but it will also update the cache. So if it's between the minimum and maximum zoom, it'll seed the cache. If it's not between the minimum and maximum zoom, it won't. Okay, so hopefully that makes sense. But now I'll just hop into a brief demo to demonstrate, how exactly we can use the vector tile cache. So for this, this is the SQL developer extension for VS Code. And first we'll start by looking at our data. So I have a small data set here of buildings in Boston. And you can see, we have our geometry column, we have an ID, as well as, the local ID, structure ID, and square footage, right? So I can now run this get vector tile function, and we can see, I have my Boston buildings table name, a geometry column, and then those extra attributes. And if I run this, okay, we can see here at the bottom that we are returned, we get a vector tile returned back to us. And so if we look at our cache table, we'll see that there's no row selected, meaning that our cache isn't enabled. And so if we look at, our vector tile cache table as well, we'll see that we don't have any tables. So to clarify, so we have an info table and the cache table. So the info table basically stores the information about, when we enable the cache, what the information that we're caching versus the cache table is the actual the data itself that we're caching. I hope that makes sense. And so from here, we will enable our vector tile cache. So when we do that, we'll be able to see, let me clear this. We'll be able to see when I run this get vector tile function, we're returned back our vector tile again. But if I look at our info table, right, we get a result back. So we get all of those attributes that we declared with the get or with the enable vector tile cache, right? So I left it at the default. So the zoom is between 0 and 23. but we have that Boston Buildings table name and we have the geometry column as well. And if we look at our vector tile cache table, we can see that we have our tile key, the table name, the geometry, the tile zoom, right? So all of this information that we're getting back, as well as the tile, is getting stored directly within our vector tile cache table, right? And so, the idea here is to optimize for performance. Obviously, we're only looking at one table or one tile. So we're not going to see significant changes in performance, but within an application, because we would be streaming lots of tiles all the time, this cache can, improve performance pretty significantly. And so if I clear this here, the next thing I'm going to do is I will purge our cache just to show that when we purge it, this doesn't purge our info table, but it does purge our cache table. So if, for some reason we were seeing some kind of like our cache builds up too much and we're seeing a decrease in performance or something like that, we can purge the cache and then it will start repopulating with the same, tables that we enabled the vector tile cache for. And then lastly, we can disable the vector tile cache. And if we do that, that will remove that table and geometry column from our info table as well. Right. And so from here, the last thing I really wanted to touch on is this idea of an automated cache maintenance. So one of the problems that you might imagine is if you create this cache and then you update a series of either the attributes or the geometry column itself, are you going to be pulling that updated information? And so with the vector tile cache, there's a series of triggers that are created on the source table in order to keep the cache updated at pretty much all times. So anytime you make an update to the source table, it will be updated in the cache as well. Okay. And so that is pretty much the end of what I had. I ran a little bit fast, but if there are any questions, I can take those now. And I'll stop sharing.
Thanks a lot, Rahul. I don't see any questions, but it's time now to raise those. I think it's an exciting topic. We've already talked about it in several sessions, and it's very important for application developers, this feature, since it can handle very large amounts of spatial data very efficiently, plotting those on maps. So it's a technique everybody who is interested in integrating maps in your applications should have a look at. Okay, so no questions so far. Then let me take over and share my screen for the last topic of today.
Sounds good. Thanks, Karin.
Thank you, Will. Okay, so the motivation for this topic is actually that everybody is talking about generative AI, select AI as part of the database version 23 AI. And we wanted to check how we can use select AI to generate spatial queries from or using natural language, and then seeing how well those are constructed, the queries, how well are the spatial functions and operators supported. And this is why I picked this topic and want to give you a short introduction today with the first steps in setting up the prerequisites to use Select AI, and then doing tests with common spatial operations and functions, and see how the large language models supported by Select AI are able to generate spatial queries. Okay, so much about the motivation. Let me just briefly walk you through some some prerequisites and some general information. Just to have a view on the data sets, I'm using different data sets. Of course, I know the US is not the center of the universe, but since I have the data sets already available, I just picked those data sets representing airports, earthquakes, hospitals in the US, or cities and states, doing some queries or tests with those data sets. So you just remember that I'm going to use these data sets. And what you can see here is actually a view with Spatial Studio, or Spatial Studio displaying those data sets. With regard to generative AI and using large language models to turn natural language into SQL queries, so there are different areas covered, or different things you can do with those large language models. And the two things we will be looking into today is interacting with large language models from SQL, or generating SQL queries using natural language to generate using natural language together with database metadata, and then generate the actual SQL queries. And of course, we want to focus on spatial features and functions. So the support for large language models together with Oracle Database 23AI is well documented. Maybe you have already started to look into the features provided with this version and what Select AI specifically can help you with. So just to make you aware of which language models are supported. So there is this native OCI generative AI service, but we also support OpenAI or Hugging Face or Cohere, so other service providers for AI. The actual things what you can do when running Select AI is first creating or generating a SQL query and running the SQL query directly to give you the results based on natural language you provide as a prompt to the Select AI statement. The second action you can do is showing the actual SQL that is generated, and then you can take the SQL, verify it, modify it, and run the query on your own. You can also explain SQL. So this is the function to explain the generated SQL query. You can also use a function called narrate to return the result into a kind of story. So putting some more meat on the result in terms of actual information, and also a chat function that directly uses the large language model to generate the response to a prompt. So these are the 5 actions what you can do when running Select AI directly in the Oracle database. And when it comes to what's happening behind the scenes, here are the examples, or here is the actual pipeline, what's been done in the background to either show SQL, run the show SQL action. So here is what you can actually, what is actually done. So based on the metadata describing information about the data in your database, putting it together with the prompt you provide for the SQL Select AI statement. For example, what are your top 10 stream movies, or find the top 3 baby boomers, big spenders, or we will be seeing more examples using the spatial data. Then this is put together as an augmented prompt and sent to the large language model, and the result of it is a SQL query generated from it. This is the general pipeline, what's happening in the background. There are a few prerequisites when it comes to use a large language models. The first is that we need to set up network AC outs to reach out to those services. And also we need to create credentials in the Oracle database that allow users to reach or to use those services. So these 2 things are prerequisites. The correct examples for it we will be seeing right away in my demo. And the third thing what you need to do beside the ACLs and the credentials, you need to set up a profile. And the profile defines which service endpoint, AI service endpoint you are going to use. So this is the provider here, and also which large language model that is provided via this service provider you want to use. And when I talked about the metadata of the database objects, this is what you can see here as object list. Here you can specify which objects in your database schema you want, or in your database schemas you want to use in order to implement the prompt with actual data from your database. And this is defined here. So we are going to use a few of the data sets available for the United States and the earthquake data set with worldwide data. And once we have done this, we define that we want to use this profile in order to ask to generate the SQL queries based on the large language models provided by OpenAI in this case. Okay, and here is a visualization of the pipelines for the other actions like run, SQL, narrate, and chat. And I just want to show you how you can find your profile in order to not only use the metadata telling which tables from which database schemas you want to use, but also to make your profile or the database aware of information about your tables and also about the columns within your tables. So it's always a good practice to provide commands for your database tables for the columns, because those will be used or can be used once you specify commands true in the profile. The commands will be used to enrich and augment what's sent to the large language model in order to create the SQL statements. So this is one of the very important things, parameters within create profile commands, set commands true. And of course, if you set it to true, your tables and columns should have some commands, meaningful commands assigned. And the second parameter which you can use to augment the large language model is conversation true, which means that there is a kind of chat history when asking questions via your prompts. So the previous answers will be kept and the subsequent questions will be added to the previous results in order to enrich the result set with the one question after the other. So this is about the parameter conversation true. And I think so far as I remember, you can have up to 10 subsequent prompts to refine your actual query in order to generate the SQL statement you would like to have at the end, and which gives you the right answer when querying the database. Okay, there are a few more parameters. I haven't used my demo in order to fine-tune the model, but I just want to start with those parameters here with conversation, with commands, and the actual model, and of course, specifying the provider. Okay, let me go to my demo part, also using SQL Developer within Visual Studio to walk you through my demo part. And as I've told you, there are a few prerequisites. First, I want to make sure that I'm able to generate queries for database tables contained in a different database schema. So a typical use case is that I have an application user which is used to create my Apex applications. In my case, this is called Apex user. And this Apex user has permissions to select data from tables in the schema Spatial user, and specifically those tables are used counties, hospitals, and so on. So these 6 tables are owned by Spatial user, but the Apex user has permissions to select from those and build an application. In order to generate or to use Select AI to generate SQL queries, this user, the application user, needs to have permissions to execute the 2 packages. It's DBMS Cloud and it's DBMS Cloud AI. So I have granted these permissions to both users, Spatial user and Apex user, just to make sure that I can also use Spatial users to run those things. Then part of my test was to actually figure out which large language models are best suited to generate SQL queries. And if you ask, for example, ChatGPT, which large language models are the best ones to generate SQL, very often you will see that OpenAI is very well suited to generate SQL. And this is what I will be focusing on, using OpenAI as a service provider, and with the large language model and also with the model GPT-4 to generate the queries. But I could, of course, use other service providers as well. And part of future studies will be to compare the different large language models also for the spatial queries that are generated. Okay. So for the prerequisites, I told you that we need to create the necessary ACLs for these service providers. So here it is for Cohere. Then for OpenAI, I have these two statements that allow the user, Apex user, and also the spatial user to reach out to that service. Since I've already executed those statements, I'm not going to do it again. Then the second prerequisite is to create the necessary credentials. And what you can see here is hopefully, the connection is still in place. Here we have the credentials already set up for several services, the credentials for the Cohere service. Of course, the API keys here listed here for OpenAI and Cohere needs to be replaced with the proper keys. And once you have done this and called create credential, then the result will be listed here. So I have credentials available for 3 different services, AI services or AI service endpoints. Okay, so then the last step is to create a profile. We check whether there are already profiles in place. I do have 2 profiles defined, OpenAI and Cohere. I'm going to drop those right away just to start fresh. And here is the way how you define the profile. Let me just execute the second one, which uses OpenAI. And once I've done this, let me select it. So here I have the new profile, OpenAI. What you can see here is that I haven't included comments. This is on purpose because I wanted to do it without the comments, and then again with using the comments on tables and table columns. So we see hopefully some difference in using it without or with comments. And what I'm going to do next is using that profile in order to generate SQL queries that also use spatial or shall use spatial functions. And the purpose is to see how well the large language models are aware of SQL or spatial operators and functions to generate those queries. What I'm going to do first is I'm going to set the profile for the session. This needs to be done for every session. And then I can go ahead and use Select AI either directly, or you can also use it via this cloud dbms_cloud_AI generate, and then you provide as a parameter the prompt here, the profile name, and the actual action. And this is what I'm going to do right now. So my prompt is, what is the total number of cities in the US? And you remember that I have a city, I have a table called US cities. And once we look at the query generated here, is so far it doesn't seem to be a problem to figure out the number of cities based on my table US cities in the database schema spatial user. So this is well done so far. Nothing specific with regard to spatial, but to just have an easy start, the total number of cities, and then running the SQL query, the actual query using the action run SQL. And again, having also the action chat, we can see here that it's behaving differently since this prompt is directly set to the large language model. And here we get as a result that the model is sorry to let us know that they don't have real-time data about earthquakes that happened near Juneau International Airport, but I asked this question on purpose because we do have data about airports. We do have data about earthquakes, and we want to see their spatial relationships between earthquakes and airports. And this is why I wanted to know whether these questions can be also answered by a large language model without using actual data. So when we go to the next query here, which asks whether or which earthquakes happened near Juneau International Airport, and now asking for show SQL, then we can see here that we have a completely different SQL statement. So what we see here is that we have this table USGS earthquakes is one of our tables, then the US airports. Then we want to see just the airport, Juneau International Airport, and all the earthquakes that are near, or in this case, the SDO within distance function is used to find out which earthquakes are within distance of 100 kilometers of Juneau International Airport. And this is actually a query which we can directly run. Let me just put that in. And we will get a result, which is this one. And this is, I've verified it before. When we run it using the different tools, we'll give the same result. So this is pretty okay. Even so, which earthquakes happen near Juneau Airport, International Airport, could also be answered using the SDO nearest neighbor function. So within distance is one option to run the query, SDO nearest neighbor, with a result set limited to n nearest neighbors is also a very good option. But we can see here that without giving any detailed information about which SQL function or spatial function we should use, the return SQL already is location aware and spatial function aware. Okay, so let me go further down. And very common questions or queries with regard to spatial data are so-called spatial topological queries or searches. And here we are going to ask which earthquakes interact with the state of California. And those who are familiar with spatial functions and operators know that there is an SDO any interact operator and also a function SDO relate with a masking operator SDO interact. So let's see whether we get a result that is reflecting those functions. Did I run the statement? Yeah, I did. So let me show that. Okay, so here we go. Here is mask any interact. Here is SDO relate, which is the spatial filter for topological relationship with masking operator and SDO any interact. And we have spatial operation, which tells us that we are going to search for the earthquakes that are interacting with the state geometries. And let's run this statement as well. And here we can see that there are plenty of earthquakes in our data set that are interacting with the state of California in this case. So without much information, just taking the tables and the data from the tables, we can generate this. We have a SQL statement that is giving us the result we are looking for. And even the parameters in the SDO relate function are in the right order to perform well. You might remember that there is best practice also with regard to SDO relate, in which order you should use the two parameters, the two geometries from the different tables, and these are in the right order already. Okay, so another topological operation is counties that overlap with the state of Wyoming. So we have counties in one table, states in another table, and those should be overlapping. Let's see what the result of which SQL statement is generated for it. Okay, this looks pretty good. So we have this SDO overlaps operator here with the different parameters, and inside the second parameter is actually a select statement using the filter of the state Wyoming, and then we can run this one as well. There is one problem here. Those data sets, the counties and the US states, have a column called state. And this is causing a problem here because it takes the state from that US counties table and returns this one in my data set. And this actually gives kind of weird result I'm not looking for, because what we see here is that we are that we get returned the state of Colorado, Idaho. So we are wondering why this state is coming, but it takes the actual value from the state column in the table counties instead of the state column in US states. Okay, so if we change that one to states, this one to county, state, I think the right attribute is name. Okay, yeah, something is not working well, but yeah. I just wanted to make you aware of the problem that you have columns with the same name in different tables, and then there can be an ambiguity in the result set and the results you are not looking for. Okay, so since we are already over time, I'm sorry for that. I just going through what I've prepared next. So adding columns to the tables and the actual comments to the columns and the tables is what you're looking here, seeing here. Then we recreate the profile now using the commands, and then running queries again using the profiles, using the new profile, which includes the commands, and then you might get better results. And from what I've seen, the results are better, but you still need to provide or give detailed instructions on what you actually want to see. So here, for example, I asked which counties interact with County Hot Spring, and you can, sorry for that. Okay, so which counties interact with County Hot Springs, and maybe you need to add some more instructions like this one here. Use a specific operator or a specific function to get the proper result or to generate the SQL query you're looking for. The same something I've done here in this prompt. So I told the prompt via the prompt that it should use the corresponding spatial functions related to insight and overlap in order to generate the right query. Those things you can specify via the prompt, and then narrow down how you can actually generate the query you are looking for. I've also done some tests with regard to generating data definition statements. For example, generating the statements to create a spatial index. And this is what I've asked here. So what are best practices to create a spatial index? So generally asking the large language model, and later on also asking to generate the actual create index statement as well. And the results of it I'm going to include in one of our next sessions. So let me just go back to kind of summary from our observations using the large language models, especially the tests I've done with OpenAI and generating SQL queries. Also using spatial operators and functions works quite well. Not always it gives me the right results, but the more precise and detailed your instructions are in the prompts, the better the results are. Also, I always recommend to add the commands to your tables and columns and include those in generating the SQL queries. As I said before, make sure that you use the right columns from the right tables in order to give the proper results back, especially when the table names are redundant or table names like state are used in different tables and also used in the prompt. And of course, you should always be aware that there are hallucinations. For example, when running the chat function to generate a query for creating a spatial index, that doesn't give proper result yet. So use the tools at your hand and also the documentation to always validate queries and see whether they are correct. Okay, so everything I've used for preparing the first part of Select AI part, I've included here. There are more resources for spatial technologies via these links. And our next Ask Tom session is planned for February 25. As I said before, feel free to send us the topics of interest. We will be including those in sessions if you send them to us. So just let us know. Let me check whether there are any questions which the colleagues haven't taken care of yet. Martin, is it planned to use domains and annotations? As far as I know, it is planned. I'm not 100% sure how far away we are into using domains and annotations, but this is something to come for sure. Good question. What if you spell California wrong? Let me take this as a question to one of the next sessions when I continue talking about using Select AI. UDIT S is used only in the Scala query. You cannot use it outside. Okay, so this is why I got the error message when I modified my query. Is that correct, Judith? And thanks a lot for the feedback, Judith, as well. So, okay, perfect. Thanks. Any other questions? Okay. If not, I'm sorry for keeping you longer than expected, and I hopefully see you next month. Thank you for joining us.